There are many abstract ideas and terminologies associated with quantum computing, including some fundamental theories such as QED, quantum electrodynamics.
So what is quantum electrodynamics? That's the study of atoms and electrons coupled to photons, to particles of
Recently,
light.
I have found a very economic method for understanding quantum computing, particularly on how and why some hot issues have been discussed in traditional media and on internet. A shortcut for many people, so to speak. Today, I'm going to share with you this method step by step. So are you ready? Let's go and have fun. Do you know the first quantum computer was built on a commercial pulsed NMR spectrometer? In 1998, Chuang et al. Published this paper in which two spin-coupled nuclei, namely proton and carbon-13, were used as two qubits to perform Grover's quantum search. Why did they choose a commercial NMR spectrometer instead of other homemade qubit devices then? That was the question I asked. Well, it turned out that almost all essential ideas and techniques in building a quantum computer come from the early studies of nuclear magnetic resonance and electron spin resonance. In a simple pulsed NMR experiment, one can use a pulse to create an initial quantum state, and then use another pulse to detect the time-dependent signals, such as hand echo. After using Fourier transform, one obtained a spectrum. Further, one can add another pulse or several pulses between the initial and the final quantum states. In this way, a quantum coherence pathway is created before the coherence disappears. Sounds familiar? Indeed, this is exactly what researchers have been doing in developing quantum computers, namely to build, test, and implement a sandwich with a number of logical gates based on different algorithms, where each logical gate can be represented by a pulse or a pulse sequence. For example, in this 1998 paper by Chuang et al., the Walsh-Handmart gate that rotates each quantum bit or qubit from state 0 to state 0 plus 1 divided by square root 2 in order to have a uniform superposition state, where the Handmart gate is achieved by applying several half-pi pulses or 90-degree pulses in a proper sequences. In general, a Handmart gate might require a combination of half-pi or pi pulses with specific phases. As you can see here, every gate can be denoted by a matrix. Perhaps you know every operator in quantum physics can be written as a matrix, using the eigenstates of Hamiltonian as a basis. If you have studied linear algebra, then you can understand that a new quantum state or vector can be generated by multiplying an initial state using a matrix. Also, an effective Hamiltonian is used to represent the total energy of the system in the quantum computing research, although some terms and parameters are introduced phenomenologically for the instrumental variables in characterizing qubits. The ability to express any quantum gate as a pulse sequences stem from the fact that quantum evolution is governed by the Schrödinger equation, and pulses control the time-dependent Hamiltonian. Still, some essential differences exist between pulsed NMR spectroscopy and quantum computing in achieving their own goals. The ultimate goal for pulsed NMR is to improve the quantity of the NMR spectra, both the resolution and the intensity, in which every peak is associated with resonance transition between two quantum states. A photon is either absorbed or emitted. As a result, the detection or readout is always designed to facilitate the change in quantum states under resonance condition. By way of contrast, the prime objective in quantum computing is to preserve the coherence quantum states, do you remember? Therefore, resonant absorption and emission are always avoided by all means during the readout. In a so-called circuit QED, quantum electrodynamics, both the in-phase and in-quadrature components of the signal, denoted as I and Q respectively, are recorded to visualize the quantum bits or the corresponding eigenstates, 0 and 1. In short, all pulses used in built quantum gates are on resonance, so that both the two energy levels, 0 and 1, are occupied by spins or other quasi-particles, like fermion or bosons. But the readout pulse is always off resonance in quantum computing. Of course, since 1998, many non-NMR devices have been used to generate long-lived quantum coherence or quantum bits. But the principle for manipulating qubits based on different quantum algorithms are almost the same. If you can find a good NMR textbook and naturally watch this channel on tuition, then you should be able to understand many research topics on quantum computing and those fancy wordings repeatedly used by those CEOs and the quantum trade spokesman or TV commentators. Thank you for watching. Please make some comments and subscribe. See you next time. The blue curve is theoretically calculated, which is to be explained soon. As you can see, the coordinates of the three planets, namely Mars, Earth, and Venus, can be quantitatively predicted. Is that beautiful? I remember my teacher said Newton was merely puzzled by the first push because he believed that his mechanics to fix the fundamental problems of the standard model, isn't it? Let's remember C.G. Ozawa, my favorite conductor, who created joy. Arrhenius claims CO2 is the chief absorbent on his paper, page 260, without any direct experimental evidence, such as this one demonstrated with this Newton's cradle. As you can see, something must have been transferred among the metal balls. But what is this something?